Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem. We're taking a look at all the cool technologies in this growing field of big data, and we got a whole bunch of good stuff lined up for you today for folks. And the first one I'm really excited about. This is a company we've been following for the last few years, last couple years at least, very closely, a very, very powerful database technology. We're going to be talking to Seth Proctor of NuoDB. So with that, Seth, I turn it over to you. What you got?
Great, thank you. Hey everyone, this is Seth Proctor. I'm the CTO here at NuoDB. As you just heard, yeah, the data space is a really interesting place to be right now. There's lots of cool stuff going on. What I'm going to show you today, I hope falls into that category. I hope you all think this is kind of an interesting, different take on what you can do in the distributed database space. So for those of you who are unfamiliar with NuoDB, essentially what we're doing here is we're providing a relational database, but a relational database designed around a fundamentally new web-scale architecture. So it's a traditional database in the sense that it's SQL, it's fully ACID, it speaks all of the standard JDBC or ODBC or .NET Entity or PDO or whatever SQL interfaces you're used to working with. But it's designed around a fundamentally new take on what a distributed database should look like. And we call it a durable distributed cache, but essentially it provides a way to scale out on demand so that you can get elasticity, you can maintain availability in the face of failure and upgrade, so you get true continuous availability. It can run across a single data center, but it can also span multiple data centers and still give you that true ACID view of the world, but low latency and highly available. It supports some really interesting multi-tenant use cases. And fundamentally, a system like this is very complicated, and so we've worked very hard to make it simple to work with. And what I'm going to show you today are kind of some of these use cases all rolled into one demo. And what I'm going to try to show you is that when you're looking at databases for the cloud and you're thinking about how to get into either a public cloud environment or how to take your single instance database and get it running across multiple servers in your local data center or whichever resource you have available to you, that there are some kind of fundamentally different and interesting questions you should ask yourself about what the architecture is that you're building around and what it enables. And so what you've got in front of you right now is you've got a new tool that we've been working on here at NuoDB. This is a new web console that's designed to be a very simple, streamlined interface. When you deploy NuoDB, what you're really doing is you're going through a provisioning step. You're installing software on a machine, and you're making that machine, whether it's Windows, Linux, Mac, whether it's a virtual machine or a physical machine, you're making those resources available. And then we provide an administrative layer of the system. We provide monitoring capabilities, management capabilities, so that from a single place, you can keep track of all those resources you've provisioned. And that management tier is available through Python APIs, Java interfaces. It's available through REST calls, a command line tool. So it's something that you can plug into your existing framework, but we also provide a simple GUI to get you started, and that's what you're seeing here. And what I've done, what I did this morning before this call was I set up a number of virtual machines on Amazon, on the AWS EC2 service. And you can see that once I've got those instances running, from a single place, I can monitor all of my resource management. So I can kind of start to solve standard systems administration tasks right here. I can see things like the average memory utilization across my hosts. I can see things like CPU utilization. And I can very quickly, from a single point, keep track of the fact that everything seems okay. We can see there's one host here that's doing a little bit more activity than all the other hosts. And that's because it's the one host I have that's actually driving this management console and is collecting some statistics. And we'll look at a little bit more of the statistics as we go along. But this is the first thing I just want to show you is that part of what we've done at NuoDB is really focus on making the task of operating a distributed database really simple. All right, so this is about databases. Let's get a database running, because right now I've got a bunch of machines, but I don't actually have my database active. So what you can do with NuoDB, and again, you can do this from APIs or you can do this from the GUI, is I can say what I want is just to start a database. And I'll pick a name for my database, I'll pick an initial DBA username and password, and then the last thing I'll do is I'll pick a template. And a template is essentially, it's a service level agreement. It's a declarative definition of what the problem is I want to solve with my database. And since you're just getting started, since you haven't played with NuoDB before, what you might want to do is kind of run something that's similar to any other database. If you run something like an Oracle or a SQL Server or a MySQL, or you're used to playing with like Mongo or something just on a single machine to get testing, we'll do that. We'll start with a single host. I'll click Submit, and our software will go off and we'll start that single database. So what I've just done is I've got a single database running on Amazon Web Services, and there we are, and our software is automatically monitoring it. So you can see it's active, it's running kind of at its specification. And what we've really got is we've got a database running on a single host made up of two processes. And if you click through, you can see we've got what we call a storage manager and a transaction engine. And essentially, these are the two tiers of our system. The transaction engine is what SQL clients talk to, is responsible for doing transactional processing, and is an in-memory process. So it's a caching tier, it's an optimization tier. It handles all the correctness and consistency in the system. And then we have another tier called the storage manager that's responsible for data durability. If you go to our tech blog, or if you go to our website and download our white paper, you can learn more about this architecture. But the important thing here is you didn't have to understand how all these pieces work, right? What you got was you got a database. And by a database, I mean you have a single logical database. Your application now just has a single JDBC connection string it can use to start talking to this database. And there's no sharding, there's no notion of active roles or passive roles, there's no kind of multi-master replication. It's really a single logical consistent database. So this is a good place to start. We're on a single machine. And that may be useful for things like dev test, or that may be useful for lightweight services that you want your users to be able to spin up on demand as they need databases. That might help simplify your operational world. It might kind of take some burden off your systems administrators and DBAs. But it's not very exciting yet from a distributed database point of view. So let's assume that time passes, you've gotten comfortable with this database, and now you really want something that you feel more comfortable deploying. You can just go into this same tool we had, and you can say, I want to edit this running database, and now I want to change its service level. I want to change it from running on a single host to being what we call minimally redundant. And essentially what that means is we'll guarantee at all times that there's at least 2 of those in-memory processes and 2 of those durability points, so that any part of the system can fail at any time and your database is still fully available. And so I can just go in and change the template that this is running against. And you can see what's just happened is now it's reconfigured itself. And now it's a database running across 3 machines. It's a database that's supported by 4 of these peer processes. But from a SQL applications point of view, it still is just a single database. And so I can do that live without having to take down a database application, without having to upgrade the application logic. There's no change in the environment. There's no change in configuration anywhere. I just expanded this live. And now my application that used to have only a single host to talk to now has 2 hosts to talk to. And so we've made that process of being able to expand really simple. And now you have a database that is running in multiple places and provides resiliency, has given you scale out, and is still something you can monitor from a single place. So I think that's pretty cool, but we can go a step further. And I said we're running in Amazon. We're actually, if you look here, you can see that where we're actually running is we're running across 3 regions in Amazon. We're running across US East 1, which is Virginia. US West 1, which is California, and US West 2, which is in Oregon. But right now, we can see that the database we've been running is just running in the East region. It's just running in Virginia. So I can go back to that same view where we just were, and I can say, this database that's live, that's running, now I want it to grow to run in multiple regions. I want it to be geo-distributed. And I might want that for a couple of reasons. I might want that for high availability, so that if any region goes down, my database is still running. But I might also want that for low latency, because I may have users on the East Coast when I started, but now I may have users out on the West Coast. And I'd really like to give them low latency access to the application, to the database, the same way that my Virginia, my East Coast users have low latency. So I've gone in, I've changed the template, and what you see in front of you now is the database has reconfigured itself. And now it's actually just automatically expanded to take advantage of all 12 virtual machines I'm running on. And for those of you who are curious, I'm running on the smallest of the R3 instances on Amazon. So these are memory optimized instances. These are not very high-end machines. They're not particularly expensive. You really can run this on kind of basic Amazon infrastructure. So I'm running across 12 virtual machines on Amazon in 3 physical regions. I'm now running across my hosts on the East Coast and the West Coast and up in the Pacific Northwest. And it's reconfigured itself to be these 16 independent processes. But again, from the point of view of my application, it's still just a database. So nothing changed in my application logic, except now if I spin up, say, web servers or app servers in the California data center or the Oregon data center, I can get nice low latency access to my database. And that's pretty neat. I guess that's really cool. And that's really important when you're thinking about moving to a cloud model, whether it's on your own infrastructure or public cloud, is that flexibility. The ability to change your operational model without affecting your application logic, the ability to run in multiple places without having to kind of have weird tanglement and coupling between those 2 layers, and this kind of flexibility where you can really choose where to run, right? But there's another really important thing that people want flexibility around when they think about where do they run. And that may be that Amazon is great, and Amazon is great. It's a great environment for developers. It's very simple to work with. It's really powerful to get up and running. But there are a number of reasons why you may want to be able to run elsewhere as well. And one great reason is when we look at the regions here, we see I've got data centers on the East Coast and the West Coast, but that's kind of unfair to the rest of the continental United States. It turns out there's a big part of the country between the East Coast and the West Coast, and they're not represented here. And that's because Amazon doesn't have a data center in the middle of the country. There's no way to add resources so that if someone, say, in Texas wants to log in, they can get that same low latency experience as someone in California. And so what I'm actually going to do now is I'm going to expand the database further. And the way I'm going to do that is I've just gone over to a couple terminals where I've got virtual machines set up on the IBM cloud on SoftLayer. And so what I've just done is I've started 2 instances over there. And when I come back here and look, now what's happened well, ladies and gentlemen, this is always the challenge of doing a live demo, is sometimes it connects, and try that one more time. Well, what I was trying to show you, and I apologize because I took a recent build of our software and apparently I should have dialed back a little bit this morning, but what I was trying to, oh, there we go. Just took a minute to actually come live. So what's happened is I've brought online instances in the SoftLayer region. And in SoftLayer is an IBM cloud. It's like Amazon, but it has data centers in different parts of the world. And in particular, it has data centers in Austin, Texas. And so what I've just done is I've brought online virtual machines in Texas. And what you can see now is my database is automatically expanded. So that now I'm running in 4 regions instead of 3 regions. And I'm running more processes across more hosts. And if I click through, I can see it's now reporting that I have a host called a region called US Central. And of course, there is no physical region in Amazon called US Central. But what I've just done is I've brought resources online in Texas. And I apologize for a little bit of a glitch there in the demo. We'll make sure we've worked that out before the final version of this GUI ships later this summer. But what I've just done now is I've added to my total list of hosts, I've expanded my database, and because my database was running against one of these templates, it expanded automatically. And so now for users in Texas, they're also getting that low latency access. But more importantly, for you as you're thinking about where you want to run, right? Your concerns may be around low latency access in places where one cloud provider does not have resources. Or your concerns may be about being able to run in your local data center and then also being able to expand to resources in a public cloud. Or you may be providing a service and you have some customers who are running on Amazon, some customers in SoftLayer, you may have customers on Rackspace or customers in Azure or customers in the Google Cloud. And you want the flexibility to be able to support them in all those environments. Or you may simply not want to be locked into a particular stack, a particular set of APIs, a particular set of tools. And so what we've done here is we've given you that kind of flexibility, the ability to choose where you want to run, the ability to run across multiple sets of infrastructure, and the ability to still have a simple management model where you can take advantage of all those capabilities. And I'm going to end by going back and showing you the screen we started with here, where I was doing management across all of my resources. And I talked earlier, I said here we have, here we have the average host utilization I can watch, we have CPU utilization. But over here I'm watching network traffic, and I'm watching inbound network traffic broken down by region. And what you can see here is kind of for a while there wasn't a lot of activity going on because all I was doing was monitoring. And then I started actually running a database, and so there was, you can see a little bit of activity, not a lot, but a little bit of activity between regions. And then as I brought a 4th region online, you can start to see the activity going on between these 4 regions. And so again, whether you want to use these tools or you want to use our APIs, we provide a very simple place operationally to understand what's happening as you expand across multiple clouds. And I think when you think about the problems you're trying to solve, when you think about the infrastructure you're trying to deploy, it's not just about kind of can a given tool work in multiple places, but what will be the complexity, what will be the overhead of trying to manage that, of trying to monitor it, of trying to understand how your resources are being used in those multiple clouds, and what kinds of application use cases does it unlock. So here at NuoDB, we'd like to think that we're providing a really powerful general purpose SQL database, but one that enables you to run across multiple places and then makes it easy enough that operationally you can actually take advantage of it and treat it like a single logical database and a single logical kind of operations point to manage. So I'm going to stop there and I'm going to see if there are any questions about what I've been showing.
Well, I'll chime in here. I think this is really quite fascinating. So you are enabling a very simple user interface to an array of servers that constitute a single database instance, basically, right? Because you mentioned there's only one JDBC connection that feeds various applications from this database. Is that right?
That's exactly right. So as I expanded from running on 1 machine to 4 machines to 12 machines to 14 machines, it was still the same connection string from the SQL client's point of view, and the client just kept running, right? So you can expand on demand. I could also start killing these machines. I could take them away, and all the client will see is just a disconnect, and it just goes through a standard JDBC reconnection, and it's back in the database and keeps going. What's also really cool here, I didn't show this, but this is all running in a multi-tenant model. So I could start a 2nd database on some of these machines, or a 3rd database, and again I can monitor all that from the single point. So you're exactly right. I've got this nice, simple, single logical database, this nice, simple, single logical management point of view, even though I'm running operationally in many different places.
Yeah, and how can you be dynamic in terms of spinning up additional machines? In other words, like your website gets a whole bunch of traffic because it's at the end of the year, it's the Christmas season or something, and there's a spike in traffic and activity. Can you dynamically spin up instances like that?
Yeah, and that's essentially what I just did with my SoftLayer instances. Was I just started the software running on them. It's kind of like watching paint dry, which is why I don't, like as part of my demo, show starting Amazon instances. But I could just go right into the Amazon Web Console right now and just click and say, start a couple more machines in one of these data centers or in a new data center. And we'd wait a minute for the machine to come online, and then it would just start participating.
Yeah, that's fantastic. Wow. And it seemed pretty cool the way you can go to different levels of the database, from a simple version to one that's minimally redundant, and then you had a couple other layers in there as well. What were those other layers?
Oh yeah, so we have a couple different layers, I showed kind of a single host machine, a minimally redundant machine, what we call a multi-host template, which is just a template that says take advantage of the resources in a single region. These templates, by the way, these are just defined through a very simple declarative language, and so this is actually something a user can customize. And so if you're thinking from the point of view of like you're a SaaS operator, or you're doing systems administration for your company and you want your users to be self-service, you can essentially define a custom template that meets the requirements that you care about, and then just let other people walk up to the software and say, I want a database that meets that service level. So these are all user definable.
Okay, so the question, I know this is a hard question for you to answer, but I guess you could give us just some idea of this. You're spinning up new instances of a database in a new region. Obviously, there's going to be a period of time where the system as a whole tries to balance things out so that the load's properly balanced. Can you give us any guide as to how long that takes if you had, let's say, several terabytes? I mean, significant amount of data.
Yeah, that's a great question. There are a couple different kinds of load balancing that happen in traditional databases when you're talking about that, and we look at it a little bit differently. So there's the client load, and there's kind of what's in cache. NuoDB has a different architecture than many other distributed systems. All of the caching is on-demand caching. None of it is kind of explicitly pulling objects into memory in known locations and trying to hash or trying to come up with some other scheme for distribution of data. The in-memory processes are building their caches based on demand. And so when I'm bringing online, say, that new region in Austin, Texas, I'm bringing online processes that start out with empty caches. And so that's done very efficiently. And then typically what happens is I then start bringing online application resources, something like a web tier or an app server or some other kind of application logic in that data center to start talking to the database locally. And so that will start driving load to the database processes there. That will start populating the caches. And for many applications, think about e-commerce sites, operational sites, logging, communications, any kind of session management, account management, any of those kinds of applications, kind of social applications, logical applications, operational applications, those will tend to bring into cache different data than what you have in your other data centers. Your users in Austin are different than your users in California, are different than your users in Boston, not just culturally, but actually in terms of the data they're accessing. And so there's actually great efficiency that you get in our system because those caches are disjoint. We can do coordination separately. There's a separate question about the data durability, because the way I was setting up these databases is providing replication at the durability tier at the same time that I was expanding the transactional processing tier. And that means essentially that your full database is available in all of your locations. And there are a couple things to think about there. One is that what I showed you actually was a real live demo. And so you really can be maintaining your data durability in one location and bring a new location online, and we'll automatically synchronize all the data into the new location for you. Obviously, that's expensive if you have a large amount of information. And so typically, if you're thinking about that database you were talking about with, say, a terabyte of information, that's something you'd probably copy out ahead of time, just because it'll be faster to take that data and snapshot it and use the tools available in the cloud to move it in bulk to the new location and then start running against it. But that's a task that we make very simple to do. One of the features that we're actually working on for a future version of the software that I can't talk a lot about yet, but I think is pretty interesting in the context of this demo, is around data storage level partitioning. And is around being able to explicitly decide that certain data is stored in one data center and certain data is stored in another data center. And that gives you operational efficiency, it gives you runtime efficiency, but it also gives you some really interesting capabilities around audit, around governance, around being able to make guarantees about where data was and where data wasn't in the lifetime of a database. And so that's something we'll be talking about in the future that I think probably at least some of the listeners out there will find pretty compelling.
Yeah. Okay, so let me ask another question, and this, I know this is also going to be slightly difficult because, but I mean, you know the technology, so you can probably answer from the technology. Let's say that I'm an organization and I have databases on site and databases in the cloud, and let's say like you demonstrated, I'm using Amazon on the West Coast and Amazon on the East Coast, and maybe some other cloud data center somewhere else. Is there any way that I can, just by monitoring the database instances in these various cloud environments, is there any way that I can know which cloud service is actually giving me a better, a better capability? Because the concern obviously is if you're running something in house and you put it into Amazon's cloud, it's not going to be as fast it's unlikely to be as fast as the hardware that you've actually configured in your own environment, which is kind of built for what you want to do. You're getting a kind of general service. So does this kind of give you a handle on that?
Yeah, no, that's a really good question, and that's something that we have not tried to bake into this GUI that's on the screen right now, just because our expectation is that as users get down to that level, what they'll really want to do is they'll want to start pulling that information into more kind of interesting, richer tools, either things they have in-house or systems like Splunk, New Relic, something like that. But yes, that's exactly what you can do, is you can start to say, let me collect the stats across what we call the domain, the set of hosts that are working together. And then let me start looking at them correlated by region, correlated by cloud type. And let me start to understand something about, what are the boundaries in terms of network, what are the transactions per second that I'm seeing aggregate versus, in each region or in each provider. Let me look at whether certain queries are running very efficiently in one cloud and less efficiently in another cloud. You can then go a step further and you can say, show me the disk utilization, show me the memory utilization, show me the efficiency in terms of, you can drill down into the stall points and kind of how resources are being used at a very low level on a process-by-process basis. So you can really understand very quickly which resources are particularly good for which tasks. So it's not even necessarily just about understanding like something is slower or faster, but you might then start saying, I want my database running in-house and on Amazon, but what I'm going to do is kind of do more analytic stuff on the database processes in-house and more kind of web-facing or operational work on the Amazon ones, because that's how I can better optimize the resources to be more efficient and to be more cost-effective.
I have to say that that's pretty awesome. I don't know of any technology that can do what you just described. So
thank you. Yeah, we think it's as we say in Boston, we think it's wicked awesome. But yeah, thank you. No, really appreciate that.
All right, well, this has been a fantastic demo, and thank you so very much. We're talking to Seth Proctor of NuoDB. This is great stuff. It fits right into the heart and soul of the big data ecosystem. So thanks for your time, guys. Well done.
Thank you very much.
All right, take care, folks. We'll catch you next time. Bye-bye.